Okay, in the last video we looked at verifying an identity that's given to you. On some of them, they don't give you both sides of the identity. They ask you to rewrite it or simplify it. So here's one example. Typically, you want to take the approach of converting to sine and cosine, but not always. Look for your trig identities as well, like we did with the verifying. But for this one, it says write in terms of sine and cosine, so it's probably a pretty safe place to start. So cosecant squared is 1 over sine squared. And then cotangent squared is cosine squared over sine squared. Okay, so if we rewrite those as sine and cosine, then we have a fraction over a fraction. So we know that we can change that to multiplying by the reciprocal. So this would flip to be sine squared over cosine squared. And then from there, it's usually fairly apparent what you need to do. So we would cancel out the sine squareds there, and we would have 1 over cosine squared. Okay, so this one says rewrite in terms of sine and cosine. So this would be our final answer. Okay, if it had said, if it had just said simplify, another possible answer could be to write this as secant squared, because that would be the same thing. Okay, so in a test version of this, you would try to match the answers that are given to you. So if it says sine and cosine, the first one would be an option. If it didn't say that, the second one, it could be the first option or it might be the second one. Okay, so you kind of just keep working through and simplifying until you get an answer that matches one of the ones provided, because you can see here there could be potentially a couple of different answers. Let's try another one. Okay, so here's another example. These are taken right out of the study plan in the book. So this one says write the expression in terms of sine and cosine, and then simplify so that no quotients appear in the final expression. So this one's saying no fractions in the final answer. So we could write this, it says write in terms of sine and cosine. So we've got sine squared theta, and then cosecant squared is 1 over sine squared theta. And from there we could distribute. So we would have sine squared theta minus, and I'll go ahead and write this out, but you should be able to see there that those are going to cancel out. So sine squared theta times 1 over sine squared theta. So those are going to cancel out, and those are going to leave a 1, not a 0. Remember, when things cancel out, you're left with a 1. So sine squared theta minus 1. Okay, so this is good. It says no quotients appear in the final answer. So this could be an answer. That could be one answer. And then also remember you've got cosine squared plus sine squared is equal to 1. So look at that. We could have another one here. If I move the, however we want to do this, if I want to move the cosine squared to the other side. Okay. And then I can move the 1. I can move this 1 over with the sine squared. So we could have sine squared minus 1 equals negative cosine squared theta. That's another possibility as well. Anytime you see sine, cosine, and 1, like any combination of those, look to see if you can make another identity out of that. So this could also be equal to negative cosine squared theta. Okay, so there are multiple possible answers for these. There's no one right answer. So if you get down to something that doesn't match, maybe just try to see if you can do more with it, or maybe go back to the beginning and try something else, because there's not just one answer to these. Okay, and here's one last example. The wording's a little bit different, idea is still the same. Simplify so that no quotients appear in the final expression. So it doesn't tell you that you have to change it to sine and cosine, but that's usually a pretty useful approach. So I would change cotangent to cosine over sine. So I have cosine theta over sine theta minus cosine theta. And then on the bottom, I have cosine theta times cosine theta over sine theta. Okay, now there's a few different ways that you could do this. You could make this one fraction and then change it to multiplying by the reciprocal, which is what we've done in some of the other ones. Just to show you a different technique, if you have fractions within a fraction like this, and we've got kind of like multiple things going on here, one thing that you can do is can just try to clear all the fractions that are on the inside. So I have sign in the denominator here, I have sign in the denominator here. What I could do is multiply on top and bottom by sine theta. Okay, so this is another type of approach. If you had gotten a common denominator, like if you had multiplied this and then multiplied by the reciprocal, that's totally fine too. So this is a different approach. So on top, I need to distribute. Okay, so I'm going to take this, I'm going to multiply here by sine, I'm going to multiply here by sine. Okay, and then on the bottom, this is all multiplication. So on the top, we would get, I'm going to go ahead and write this out. If you see this and you don't need to write it out, that's fine too. Okay. So I would get the first term times sine theta. Okay, and then hopefully you can see those are going to cancel out. And then I would get cosine theta, sine theta. Okay, and like I said, the signs are going to cancel out there. All right, that makes life easier. And then on the bottom, this is all multiplication. So you can write it all out together if you want to, but you should be able to see that the signs are going to cancel. Okay, so the bottom is all multiplication and division. There's nothing to distribute. So here I can just go ahead and cancel the signs, and I'm going to end up with cosine squared. Okay, so let's see what we have here. So I've got cosine theta minus cosine theta sine theta over cosine squared theta. Okay, now we can't have quotients in the final expression, so there's got to be more that we can do here. So if we look, all of the terms have a cosine. Okay, so you can either break this up and cancel. I guess let me do this the long way. So there's two different ways. If you haven't seen this before, if you took college algebra with me, you have. If you have like all these have cosine in them, so we know that we can cancel, but you've got to be a little bit careful here canceling over addition or subtraction. It's not the same as canceling in the denominator here. So there's two different ways that you can think of this. You can think of it as factoring a cosine out to the front, and you would have 1 minus sine theta over cosine squared theta. And then one of the cosines can cancel. Okay, and that would leave me with 1 minus sine theta over cosine theta. So that works. The other way that you can think of this is you can cancel a cosine with every term. So it's like the opposite of getting a common denominator. So you would have cosine theta, and I wouldn't normally write this out, but I want you to see why I can cancel this. So this is like the reverse of getting a common denominator. And then I can cancel one cosine with the denominator, and I can cancel one cosine here with the denominator. And then if you want, you can put it back together, because you still have a common denominator, as 1 minus sine theta cosine theta. Okay, so when I do it like the second method basically, and I would cancel like I would say, okay, I can cancel one cosine with all of the terms, and I would go through and cancel one cosine. All right, so whatever way makes sense to you to do this, just be really careful when you cancel over addition or subtraction. Okay, you can't just go, you can't do like this. This is the one thing that you can't do. Okay, you got to be careful over addition and subtraction. Okay, so now back to here. This is very much simplified, but we want no quotients in the final expression, so we would break this up, or you could have left it broken up here. So you'd have 1 over cosine theta minus sine theta over cosine theta. So we would go back to that, or if you never put it back together here, that would work too. And then 1 over cosine theta would be secant theta, and sine over cosine would be tangent. Okay, so your final answer, whichever path you took, would be secant theta minus tangent theta. Okay, so just like with the identities, you just have to play around with it a little bit until you meet whatever criteria they gave you.